Okay, continuing where we left off, this is still chapter 16, the thermodynamics chapter, and I'm going to do 45 in this video. 45 takes a little bit because there's 4 different parts, and you're asked to find delta H, delta S, and delta G using Appendix 4. So I went to Appendix 4 in the back of the book, and I wrote down all of the delta H, the delta H's, the delta G's, and the S's for each of the compounds we're going to need. And in this case, the 3 formulas, they're very similar, so they're basically just looking for us to practice using these formulas. So I'll do part A out all the way, and then I'll probably abbreviate how we do them for the part B, C, and D. So we have methane is combusted in oxygen, makes CO2 and H2O, are very common reaction that we know. And if I want to find the delta H for that reaction, I'm going to add up all the delta H's for the products in standard state, and then I'm going to subtract all the delta H's for the reactants. So delta H is going to equal products 1 times delta H in standard state of CO2 plus 2 times the delta H of H2O gas, and I should put these states gas because that matters, minus, and then in parentheses, your reactants, 1 times delta H of the CH4 gas, and 2 times delta H of the O2 gas. Okay, and we'll put parentheses around products minus reactants. Okay, and so I looked all of these up, and the delta H for CO2 is negative 393.5 kilojoules per mole. And the delta H of H2O gas, so it's 2 of those times negative 242. And that's in the first set of parentheses, minus, in the second set of parentheses, delta H of the CH4 gas, minus 75 kilojoules per mole, plus delta H of the O2. And remember, we learned this back in the fall, delta H in standard state of any element in its standard state is 0. So when you look that up in the table, it's 0. And so then to do our calculations, we're going to use our calculator and just plug in. So negative 393.5 plus 2 times negative 242 minus, and then in parentheses, negative 75 plus 0, I don't need. And we get negative 802.5 kilojoules per mole. Now to do your delta S for the reaction, I'll do that in another color. So delta S for this reaction, and these are in standard state, is going to equal sum of the products S's minus the reactant S's. So it's exactly the same as this one except they're S's. 1 times the S of CO2 gas in standard state, plus 2 times the S of H2O gas in standard state, minus, in parentheses, 1 times the S of CH4 gas in standard state, plus 2 times the S in standard state of O2. Now careful, this is not 0. The entropy of an atom is not 0 in its elemental form. And so we're going to plug in the numbers, and again, I looked these up. So CO2 is 214, so 214 plus H2O is 189 for H2O gas, minus, in parentheses, CH4 is 186, and O2, and there's a 2 in front of the O2, and there's a 2 in front of the H2O, so sorry about that. We need a 2 times 189 for the H2O, and we need a 2 times the O2 is 205, so 2 times 205. Okay, you have to use your coefficients. And again, we're going to get our calculator, so the number crunching is easy once you look them up. And we're going to do 214 plus 2 times 189 minus 186, in parentheses, 186 plus 2 times 205. If I don't put this in parentheses, then that negative doesn't get distributed to both of those. So you just have to be careful. And we get negative 4. So the delta S for this reaction is negative 4. And that's going to be in joules per mole Kelvin. Remember, joules for S, kilojoules for H and G. Okay, now we'll do the delta G part of this one. I just need to move my book a little bit, give myself a little bit more room here. Okay, so the delta G equation, same type of setup. Okay, so I'll do the delta G in red. So delta G in standard state is going to equal 1 times the delta G of the CO2 gas plus 2 times the delta G of H2O gas minus, in parentheses, 1 times the delta G of CH4 gas plus 2 times the delta G of O2 gas. And when you look those up, we're going to get the CO2 is negative 394, so negative 394, and these are in kilojoules per mole, plus 2 times the delta H of the H2O gas, minus 229, minus, in parentheses, 1 times the CH4 is minus 51, plus the O2 is 0. The delta G is like the delta H. An element in its standard state has 0 Gibbs free energy. That means an element in its standard state is not going to just spontaneously have some energy that it can do work with. It is in its standard state, so it's in its lowest state there. All right, so now we're going to do our math. So we have minus 394 plus 2 times minus 229 minus, in parentheses, negative 51. And we get